In the following two examples, we are given the derivative of some function, and we are asked to determine the critical points. Well, let's talk about what critical points are for a second. So what are critical points? All right, the critical points are wherever f prime of x, the derivative, equals 0. That's one case. And then the second case is wherever the derivative is undefined. And this could be that there's an asymptote, or there's some kind of hole in the graph or something like that. So at these points, all right, this is where we consider critical points, or also known as critical values. In these two examples, it's very clear that it's just going to be wherever the derivative equals 0. So since we're already given the derivative, there's not much more to it other than taking each of the individual factors that were given and setting them equal to 0. All right, and so we're pretty much set up now. So in the first case, x equals -6, and in the second case, x equals -10. So these right here are our critical points, okay? And there's not much to it. I wish there was more substance to the problem, but I mean, it's pretty easy, and the point is we've already given you the derivative, so you're good to go. Let's take a look at the last problem here. It's really brief. X minus 5 equals 0, x plus 2 equals 0. So here we have x equals 5, and here we have x equal -2. All right, so there again we have our critical points. So again, like I said, you don't have much to do on these problems if you're given the derivative. If you're not given the derivative, take the derivative of the original function, set it equal to 0, you'll find your critical points. There's not much more to it. So as always, I hope this video was helpful. Remember, like and subscribe.